So looking in depth at the glycolysis pathway and trying to look at the enzymes that actually what catalyze this pathway and trying to look at their deficiencies. Another enzyme we'll be looking at is the glucose phosphate isomerase enzyme, and we're trying to look at if this enzyme actually what hits a deficient level, um how will what how okay, what will it be like? What will be the manifestation, right? So you could see this is a part of the glycolysis pathway, just trying to highlight where the glucose phosphate isomerase enzyme is useful at, okay, in the conversion of fructose 6 phosphate to glucose 6 phosphate, right? So let's have the lecture. Glucose 6 phosphate isomerase deficiency, also known as GPI, is one of the commonest causes of what? Chronic non-spherocytic hemolytic anemia after glucose 6 phosphate deficiencies or phosphofructokinase, right, deficiency. So this deficiency of glucose phosphate isomerase causes severe hereditary non-spherocytic hemolytic anemia. It also causes what? Your liver to enlarge. That's hepatomegaly, right? And it also causes muscle weakness. Those are the manifestations, right? So this hereditary non-spherocytic hemolytic anemia is a chronic hemolytic anemia ranging from mild to severe forms. The liver and erythrocyte contain excessive amounts of what? Glycolygen in this type of what? Deficiency. All right. So let's have it full now. It is actually a rare genetic disorder affecting the Epstein-Meyerhof pathway of glycolysis, leading to impaired red blood cell function. Because you see that these pathways are not just there for fun. This pathway actually provides the red blood cell with all the energy it needs. Do you understand? So, and the enzymes, they actually what? Help these pathways to actually what? Go step by step by step. Okay. So in scenarios where you're having problems with any of the enzymes in this pathway, it usually shows up. Okay. So some aspect is just for you to know that this type of condition is an autosomal recessive inheritance condition. So that means for an individual to actually have it, the individual needs to have two genes that are defective, right? It will result into what? The CNSHA. That's a chronic non-spherocytic hemolytic anemia. It has a variable severity, ranges from mild to severe, right? Splenectomy may be beneficial because probably you might have a backlogging, or let me say accumulation of blood in the liver, in the spleen, sorry, okay? So the spleen might get damaged, so you just want to remove the whole spleen, all right? Might actually help the individual. So this glucose phosphate isomerase deficiency is the most common enzyme deficiency in the glycolytic pathway, all right? Prevalence, here they said that it is the most common after G6PD, all right? G6PD. Okay, no. It's the most commonest cause of this, all right? So probably it is the most common in in the glycolytic pathway. It is estimated to be about what? 1 in 100,000 and 1 in 200,000. While the other ones I was finding 1 in 500,000 people, all right? So it's actually common. Molecular defects include missense mutations, deletions, and frame shift mutations. Now, this GPI deficiency can also lead to neurological symptoms such as what? Developmental delays, seizures, intellectual disabilities in the human being and all that. Okay. So this glucose phosphate isomerase deficiency affects the second step of glycolysis, which is a step that entails conversion of glucose 6 phosphate to fructose 6 phosphate, right? And this will lead to impaired energy production for the red blood cell, and ultimately the red blood cell will have a dysfunction, right? So that's it for the glucose phosphate isomerase deficiency as a disorder that is related to the glycolysis pathway.